Section 300.21 of the National Electrical Code states that in commercial and industrial occupancies, cables shall not be installed exposed unless permitted by Table 300.21. Table 300.21 lists assembly halls, dining halls, recreation rooms, or similar locations where large numbers of people gather as places where exposed cables are not permitted. Section 600.4 of the National Electrical Code states that in places of assembly with an occupant load of 100 or more, wiring methods shall be installed in rigid metal conduit, intermediate metal conduit, electrical metallic tubing, or other approved raceways. Fire guard sheetrock is not an approved raceway for electrical wiring. It is designed to resist fire, but it does not provide the necessary mechanical protection for electrical conductors. Romex, non-metallic sheathed cable, is not suitable for use in places of assembly because firstly, it is not mechanically protected and could be easily damaged if stepped on or subjected to other physical impact. Secondly, it is not fire resistant and could contribute to the spread of fire in the event of an electrical fault. Thirdly, it does not provide a ground path for electrical equipment, which can create a safety hazard. Based on the National Electrical Code requirements and the specific characteristics of the addition to the church, running all the wiring in Romex is not appropriate. The wiring must be installed in approved raceways such as conduit or electrical metallic tubing to ensure safety and compliance with the code. Let's elaborate further on the National Electrical Code requirements relevant to wiring in places of assembly, such as the church fellowship hall in question. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It's updated every 3 years, and it's widely adopted by states and municipalities to ensure electrical safety in buildings. When dealing with places of assembly, the NEC has specific requirements that aim to minimize fire hazards and protect occupants. Let's break down the key sections and concepts. Section 300.21 addresses the prevention of the spread of fire and products of combustion. This section states that electrical installations shall be made in such a manner that the spread of fire or products of combustion will not be substantially increased. This means that any openings made for electrical wiring must be properly sealed to prevent fire from spreading through the building. Cables, in general, should not be installed exposed in commercial and industrial occupancies unless specifically permitted by Table 300.21. Now, let's look at Table 300.21. This table outlines the types of locations where exposed cables are not allowed. Among the listed places are assembly halls, dining halls, recreation rooms, and similar locations where large numbers of people gather. The rationale here is that these areas have a higher risk of fire and physical damage due to the presence of many occupants. Exposing cables in these areas increases the risk of damage, which could lead to electrical faults and fires. Section 600.4 specifically addresses wiring methods in places of assembly. This section mandates that in places of assembly with an occupant load of 100 or more, wiring methods shall be installed in rigid metal conduit, intermediate metal conduit, electrical metallic tubing, or other approved raceways. An occupant load is the maximum number of people that a building or portion of a building is designed to accommodate. This number is determined by the building code based on the square footage of the space and the intended use of the space. The requirement for metal conduit or other approved raceways is intended to provide enhanced protection for the wiring. Metal conduit is a rigid, durable enclosure that protects the wiring from physical damage, fire, and moisture. It also provides a ground path for electrical equipment, which helps to prevent electrical shock hazards. Intermediate metal conduit, or IMC, is a lighter weight version of rigid metal conduit. It offers similar protection, but is easier to work with. Electrical metallic tubing, or EMT, is a thin-walled conduit that is also widely used for electrical wiring. It is less expensive than rigid metal conduit and IMC, but it still provides good protection for wiring. Other approved raceways may include liquid-tight flexible metal conduit, or LFMC, which is used in locations where flexibility is needed, such as for connecting to motors or other equipment that vibrates. It's important to note that fire guard sheetrock, while it provides some fire resistance, is not an approved raceway for electrical wiring. FireGuard sheetrock is designed to slow the spread of fire, but it does not provide the mechanical protection required for electrical conductors. It is also not designed to be used as an enclosure for wiring. Let's dive deeper into why Romex, or non-metallic sheath cable, is not suitable for use in places of assembly. Romex is a type of electrical cable that consists of two or more insulated conductors enclosed in a non-metallic sheath. It is commonly used for residential wiring because it is relatively inexpensive and easy to install. However, Romex is not appropriate for use in places of assembly due to several key reasons. Firstly, Romex is not mechanically protected. The non-metallic sheath is easily damaged by physical impact, such as being stepped on or struck by furniture. In a place of assembly, where there are many people moving around, the risk of damage to Romex is significantly higher. If the sheath is damaged, the conductors inside could be exposed, creating a shock hazard or a fire hazard. Secondly, Romex is not fire resistant. The non-metallic sheath is combustible and can contribute to the spread of fire in the event of an electrical fault. In a place of assembly, where there is a higher risk of fire, it is essential to use wiring methods that are fire resistant. Metal conduit, for example, is non-combustible and can help to contain a fire. Thirdly, Romex does not provide a ground path for electrical equipment. A ground path is a low-resistance path that allows fault current to flow back to the source in the event of an electrical fault. This helps to trip a circuit breaker or fuse, which disconnects the power and prevents electrical shock. Metal conduit provides a ground path because it is made of metal and is connected to the electrical system's grounding electrode system. Romex, on the other hand, does not have a built-in ground path. While Romex does contain a grounding conductor, it is not as effective as a metal conduit system. In conclusion, based on the National Electrical Code requirements and the specific characteristics of the addition to the church, running all the wiring in Romex is not appropriate. The wiring must be installed in approved raceways such as conduit or electrical metallic tubing to ensure safety and compliance with the code. It is crucial to consult with a qualified electrician to ensure that the electrical installation meets all applicable codes and standards. Ignoring these requirements can lead to serious safety hazards, including electrical shock, fire, and even death. Furthermore, non-compliance with the National Electrical Code can result in fines, penalties, and legal liability. Therefore, it is always best to err on the side of caution and ensure that all electrical work is performed by a licensed and experienced electrician. When planning an electrical installation in a place of assembly, it's essential to consider the following factors: occupant load, type of occupancy, and environmental conditions. The occupant load will determine the required wiring methods, as per section 600.4 of the National Electrical Code. The type of occupancy will affect the fire resistance requirements, as different types of occupancies have different levels of risk. The environmental conditions, such as moisture and temperature, will influence the choice of wiring materials. For example, in damp or wet locations, it is necessary to use waterproof conduit and fittings. It's also important to consider the future needs of the building when planning an electrical installation. It's often wise to install extra conduit and wiring to accommodate future expansion or changes in use. This can save time and money in the long run. In addition to the National Electrical Code requirements, it's also important to comply with all applicable state and local codes. These codes may have additional requirements that are not covered by the National Electrical Code. It's the responsibility of the electrician to be familiar with all applicable codes and to ensure that the electrical installation meets all requirements. Regular inspections of electrical systems in places of assembly are crucial for maintaining safety and preventing electrical hazards. These inspections should be performed by a qualified electrical inspector who is familiar with the National Electrical Code and other applicable standards. During an inspection, the inspector will look for any signs of damage, wear, or non-compliance with the code. They will also test the electrical system to ensure that it is operating properly. Any problems that are found during an inspection should be corrected immediately to prevent potential hazards. It's also important to have a regular maintenance program for electrical systems in places of assembly. This program should include periodic cleaning, tightening of connections, and replacement of worn or damaged components. A well-maintained electrical system is less likely to experience problems and will provide a safer environment for occupants. The consequences of using improper wiring methods in places of assembly can be severe. Electrical shock can cause serious injury or death. Fire can cause extensive damage to property and can also lead to injuries or fatalities. Non-compliance with the National Electrical Code can result in fines, penalties, and legal liability. In addition, it can damage the reputation of the building owner and the electrician who performed the work. Therefore, it's essential to take electrical safety seriously and to ensure that all electrical work is performed by qualified professionals. When selecting an electrician for work in a place of assembly, it's important to choose someone who is licensed, experienced, and knowledgeable about the National Electrical Code and other applicable standards. Ask for references and check the electrician's record with the state licensing board. It's also a good idea to get multiple bids before hiring an electrician. Be sure to compare the bids carefully and to ask questions about any discrepancies. The lowest bid is not always the best choice. It's important to choose an electrician who is qualified and who will do the job right. In addition to the technical aspects of electrical wiring, it's also important to consider the aesthetic aspects. Wiring should be installed in a neat and professional manner. Conduits should be run in straight lines and should be properly supported. Wires should be properly labeled and organized. A well-installed electrical system will not only be safe but will also be visually appealing. In conclusion, electrical wiring in places of assembly is a complex and critical aspect of building safety. It's essential to comply with all applicable codes and standards and to use appropriate wiring methods. By following these guidelines, you can help to ensure a safe and reliable electrical system for occupants. The National Electrical Code is constantly evolving to address new technologies and safety concerns. It's important to stay up to date on the latest changes to the code to ensure that your electrical installations are compliant. The National Fire Protection Association, or NFPA, publishes the National Electrical Code every 3 years. You can purchase a copy of the code from the NFPA website or from other retailers. There are also many training courses and seminars available that can help you to stay up to date on the National Electrical Code. Investing in training is a wise decision for anyone who works with electrical systems. It can help you to improve your skills, increase your knowledge, and enhance your safety. Electrical safety is a shared responsibility. Everyone who works with or around electrical systems has a responsibility to follow safe practices and to report any hazards. By working together, we can help to prevent electrical accidents and injuries. Remember, when in doubt, consult with a qualified electrician. It's always better to be safe than sorry. Electrical work can be dangerous, and it's not something that should be attempted by untrained individuals. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. By hiring a qualified electrician, you can have peace of mind knowing that your electrical system is in good hands. Furthermore, ensure all electrical installations are inspected by local and/or state jurisdictions. The inspections are critical to ensuring compliance with local and national codes. These authorities having jurisdictions are responsible for ensuring buildings in their respective jurisdictions are safe and up to current code. Do not try to bypass this critical step. Always use a licensed professional and always have the work inspected. This is for the safety of the occupants of the building. In the specific case of the church fellowship hall, it is imperative to consider the potential for large gatherings and increased risk associated with higher occupant loads. The selection of appropriate wiring methods, such as metal conduit, becomes even more critical in these scenarios. Metal conduit provides a robust physical barrier against damage, reducing the likelihood of electrical faults and fires. Furthermore, the grounding capabilities of metal conduit contribute to a safer electrical system, minimizing the risk of electrical shock. The decision to use Romex in a place of assembly, such as a church fellowship hall, should be carefully evaluated in light of the potential consequences of electrical failures. The cost savings associated with Romex may be outweighed by the increased risk of fire, electrical shock, and legal liability. Prioritizing safety and code compliance is essential to protect the well-being of occupants and to maintain the integrity of the building. The National Electrical Code provides a comprehensive framework for ensuring electrical safety in a wide range of occupancies, including places of assembly. Adhering to the National Electrical Code requirements is not only a legal obligation, but also a moral imperative. Electrical safety is a fundamental aspect of building design and construction, and it should never be compromised for the sake of cost or convenience. The use of qualified electricians, thorough inspections, and ongoing maintenance are all essential components of a comprehensive electrical safety program. By embracing a culture of safety and prioritizing code compliance, we can create safer and more reliable electrical systems for all. Finally, be sure to check all work done and check the license of the electrician to verify they are indeed licensed. By following these tips, you can help to ensure a safe and code-compliant electrical installation in your church fellowship hall.